waiting for it to connect. And you have to give a parameter now. So whatever, doesn't matter. It will just return block of code, right? Okay. Now, if you don't know the number of parameters beforehand, like for example, if you have a function like this, but you don't know how many parameters will be passed exactly, and if you want to make your function dynamic to take uh, a variable number of parameters, you can add a star here. You add a star and then whatever, like arguments. If you do this, then your function can now take variable um, number of it can take variable number of arguments. So let's say if this function prints uh, the last argument was um, and then this arguments is basically a tuple now, right? So if you pass 5 arguments, they'll be read as a tuple. So you can say -1 here. Okay. So my function, I'm passing multiple arguments. Okay. So this star here is for wait. So if you give a star here, then your function can take variable number of arguments. Yeah, and you give if you give 2 stars. So if I call this same method, but this time I'm going to give 2 stars here. So if I give 2 stars, then work. Now these are you can give you have to give key and value pair arguments, and these arguments will then be treated as a dictionary. So essentially, this arguments is now a dictionary because I've given 2 stars, and I'll have to give specific value here. Um, so let's say also print this. Let's print the arguments so that you get a better idea. Right, so essentially, your arguments is now a dictionary which looks like this. In this case, if I print the arguments, it's in the form of a tuple because I've given a single star. Right? So single star, then these things are read as a tuple. If you give 2 stars, then your arguments are read as a dictionary, and you have to specify this here. You cannot just give this. This is not good enough. Yeah. So you have to specify that this is the f name and that is the L name. Okay, then there is something called default parameter. So default parameters are always present at the end, right? So let's say I define this function called add, and then you're adding three numbers. Okay, and if I can fix the value of c to something. Let's say I'm saying that c is 10, right? Now c becomes a default parameter. Now it's not that c will always be 10. Like you can give a different value for c as well. If I say add 1, 2, 3. Now that I've given 3 arguments, it will add these 3 only and not 10. But if I don't give the last argument here, then value of c will be taken as 10. So it is the default value, but if you give another value while calling the function, then your value will be taken and not the default value. And these always occur at the end while definition. Like you cannot say b is equal to 5 and then remove the default value of c. This is incorrect. B has to go at the end then. It says non-default argument follows a default argument, which cannot happen. So default arguments are present at the end. This is fine. All right. So yeah, let's move on to recursion, which is a very interesting topic. So recursion is basically a function calling itself. This is a function calling itself. So to give you an example of a recursive function, uh, we can talk about, let's say, finding the factorial, right? So the factorial of a number. So what is the factorial of a number? Let's say if you want 8 factorial, then this is given by 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Or I can write 8 factorial is equal to 8 into 7 factorial, right? This is also right. And this can be written as 8 into 7 into 6 factorial and so on. You get the idea, right? So this is the whole idea of recursion. So if I want to find 8 factorial, I can simply call the function with 7 factorial. Okay, so let's say we have a factorial function, and if I want to find the 8 factorial, I can call the same function with 7 factorial and then multiply it by 8, right? And similarly, if I want to find 7 factorial, I'll call the same function again with 6 and then multiply the result by 7. So this is the whole idea of recursion. So if I define a function called factorial, which takes in a number n, right? So it returns n into factorial n n minus 1, right? But this is not good enough because we need a termination condition, right? So in factorials, um, the thing is that in factorials you cannot, so first of all n cannot be negative, and this terminates at n is equal to 1. So if n is 1, you know that the factorial is 1, right? So we don't want it to go into negative numbers or even 0. So essentially that is called the termination condition. So you need to have a termination condition in a recursive function. So I'll say if n is equal to 1, then simply return 1, right? Else do this. So now this is the this is the termination condition. So so if you give n is equal to 8, right? So the same. So what will happen is it will check if n is 1, and it's not, it's 8, right? So it goes into this else condition, then calls the same function with 7, and then whatever the result it will get, it will multiply it by 8, right? And then for 7 it will call it with 6 and then multiply it by 7 and so on. So this will go on until your n becomes 1. When your n becomes 1, then this condition is satisfied and the function will return 1. Okay, then you go to the next step, next level. There's a function call which would have happened with n is equal to 2, and the output is still, I mean the final output has not been returned for that call, right? So when it is called with n is equal to 1, you get 1, and then it is multiplied by 2 here, right? And that is returned to the function call with n is equal to 3, right? So for n is equal to 3, you get 2 from this call and then multiply it by 3 and then return the value to the next function call, which is for n is equal to 4. For that you will get 6 from here and then multiply it by 4, that's 24, and then that will go to the next function call where n was what? 5, so 24 into 5 and so on. So you get the idea. We can even print this. Let's print this. So we print here that the function called with n is equal to, and then n we give here, okay, and then let's call it the output and then print this output. So we'll print the output here, output generated for n is equal to str n, and then we'll return the output. Let's also print the output. Alright, now let's call this method with 8. Okay, so you can see how this is working. The first time the function is called with n equal to 8, then the output is not generated for n equal to 8. There's another function call which happens here for n equal to 7, right? Then the function call happens for n equal to 6, 5, 4, 3, 2, 1 until you get to 1. So as soon as you get to 1, this condition is satisfied and 1 is returned. So when 1 is returned, then output is generated for n equal to 2 after that. First output is generated for n equal to 1, then the output is generated for n equal to 2, then it is generated for 3, 4, 5, 6, 7 and 8, finally 8, you get this as the output, right? So this is a recursive function. All right, makes sense? Does anyone have any doubts in this? No doubts? Okay, then I have a question for you guys. Write a recursive function for the Fibonacci series. So, so the Fibonacci series, um, the first, so Fibonacci is basically a series where the every term is a sum of the previous two terms, right? And the first and the second term are defined. First term is 0 and the second term of the Fibonacci is 1. So these two are defined, and then all the subsequent terms are essentially the sum of the previous two terms, right? So the third term is going to be 1, the fourth term is going to be 2, then 3, then 5, 8, 13, 21, um, 34, uh, 55, and so on, right? So this is the Fibonacci series, um, and you basically have to write a function. Question is to write a function to print to basically get the nth term of the Fibonacci series. All right. So define a function, Fibonacci, whatever you want to call it. It takes in the value n and it returns the nth term of the Fibonacci series. Okay. So write a recursive function for this. I'll give you 10 minutes to think about it. You can even submit your answers in the chat. and I'll call the same function and say n minus 1 plus, again I'm calling the same function with n minus 2, right? Now, what are the termination, or what is the termination condition here? Um, the termination condition is that if n is equal to 0, then you'll return 0. If n is 1, then you'll return 1, right? Else you'll return this. So what is the 10th term of the Fibonacci? It's 55. Right, so we've already seen that a 10th term is 55. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So if I define a function, add, right, and this thing is adding two numbers. Although the although this is also a very short um, piece of code, but we can also write the same thing with a lambda. So I can say add is equal to lambda uh, x comma y, and it returns x plus y. So this is the syntax of a lambda function. You write the keyword lambda, then you give the argument names, right? Whatever arguments the function is going to take. Then you put a colon, and then finally you write the output. So essentially these uh, lambda functions are created when you can write a one-line expression for the output, right? If you can write a one-line expression for the output, you can use a lambda function. Okay, essentially this also does the same thing. Let's call it add underscore. So add underscore will take in two arguments and return the sum. Okay. Okay, so I'm going to give you a couple of questions now. These are all questions about creating recursive functions. Because we are done for the content, we solve these questions. I'll give you some time to solve these questions as well. So first is you have to write a recursive function to get the sum of first n natural numbers. Right, so natural numbers are integers that start from 1. Okay, natural numbers are integers starting from 1. You have to write a function to get the sum of the first n natural numbers. right? I'm also seeing another answer in the chat for the second question. So this one is very similar to, by the way, the first question. The answer is very similar to the factorial question. I don't think this needs any explanation because the exact same code was used for factorial, and instead of plus, we had product over there. The next one is write a recursive function to print the first n multiples of 5. So here is the code that again Harsh has shared in the chat. Let's see if it works. 10, 5, 15 and none. Okay. Uh, I'll do it like this. I'll say if n is equal to 1, okay, then you will return 5, else you'll return 5 plus mul of n minus 1. Now, so this method is going to give you the nth uh, multiple. So then you can say for I in range n, right? So here the range could be anything. Okay, 1 to 10. Um, okay. Any doubts?